This is a very complex report. It's very dense reading, and so what I'm doing here is I'm boiling it down to its essentials, but there's a lot more information in the reports that you can access, and I'll make reference to some of these, but I'm going to try and give you a walk through how we did our work and what we found. Really, the air quality assessment chapter of the EA is focusing on two things. We do two things in that section. One, we look at air quality information collected in and around Kamloops over the last, say, 20 years, and we analyze that to understand what the present air quality is. We do that for two reasons. We want to understand what's here now, and we also want to compare that to what our computer model is going to tell us about air quality. What our work shows is that the air quality in Aberdeen is predicted to remain good. It's good now. It's going to remain good. It's going to remain better than in many other parts of the city. For example, the downtown, Pacific Way Elementary School, is still going to be the area where it's probably got the cleanest air. And the project effects really won't be measurable in the downtown core, North Shore, anywhere outside of Upper Aberdeen. And the project operations will have very little effect on the overall air quality in Kamloops. I'm going to show three animations. What we did was we animated the city all by itself. We'll show that. I'll show maybe half of the month of January. You'll get a good smattering of what good dispersion looks like and what poor dispersion looks like. Then we'll do the project, just the mine operating by itself. And then we'll show you the mine and the city added together. The scale on the right, the dark blue is about 2.5 to 7.5 micrograms. The yellow and light brown is about 15 to 25. And the darker brown is 35 to 45. BC doesn't have a standard for hourly PM 2.5, but Alberta does, and Alberta's number is about 80. So this is the base case. And these lines you're seeing here, this is an hour-by-hour progression. Down here is the date stamp. So January 3rd, 17, 18, 20, 200 hours. So it's going pretty fast. And you can see periods when you get a bigger blob and more brown color. That's when there's stagnation. That's when there's not a lot of air moving. So that's just the city all on its own. You can see the Coquihalla Highway as well. You can see some of the PM 2.5 from vehicles on the highway. You got a bit of an easterly wind now pushing all this stuff to the west. Now it's shifted over to the west. Probably pretty high winds when you're not seeing any of this movement, the big blob. That's winds from the west. So it changes hour by hour. So to say that fresh air comes in from here is an oversimplification of how it actually works. Fresh air is coming in from the east. It can circulate in from the west. It can move around features. So it isn't all about mine is upwind of the city all the time. So this is the city. We're on about the 26th of January. So this is the same month, and this is just the mine. And most of the emissions are coming from the pit and the haul road. So this area up in here is where all the action is at, the pit and the haul road. The highest concentrations all confined within the mine boundary, and some of this just leaking out on the sides. This is a period in the first part of January is fairly windy. So there's not a whole lot going on here. Some of it's going into the city, some of it's not going into the city. There's a little bit going into the city, the Upper Aberdeen, swinging over to the east, southeast. Now you see that same period of stagnation that we saw in the city case is now starting to happen on the mine. And so the mine's influence is growing under that stagnation episode. So there's a number of things happening here at the same time. The plume is being steered by the prevailing winds, and dispersion is taking place. So as this plume is mixing with clean air, the concentration is lowering. So when you get further from the mine, the effect of the mine is actually a lot less than it is very near the mine. So that's the mine all by its lonesome, and then I'll show you the two together. What's interesting about this is sometimes you see the mine behaving all on its own. Its emissions are going one way, the stuff from the city is going the other way. They're not even kind of mixing or mingling. And then during that stagnation period, you'll see they do tend to mingle. The city and the mine emissions do overlap and act cumulatively. This is why we're not saying the mine has no effect in the city, but we're also able to say that the effects are largely confined to the mine site, and they do affect the uppermost area of Aberdeen. You can see here there's two distinct things happening. There's this happening in the city that we saw before that's attributable to the city's activities, and then this is happening up at the mine site attributable to the mine's activities. Sometimes they merge, but other times they go in opposite directions. The existing air quality is good. Our baseline information, we've compared them to standards and objectives, and while there's some challenging areas and times, like forest fires, times when there's forest fires, or time when there's stagnation, air quality in Kamloops is really good. You compare it to other places in the world, air quality is good. Air Quality Health Index is lowest category, like 95% of the time. That's a pretty good high school geometry mark, you know. 95% is pretty good. And our assessment demonstrates that the project operations is going to have a really limited effect on air quality, that it's not going to appreciably change the air quality overall in Kamloops, and the most affected area, air quality there is better than in the rest of the city, and it's expected to remain good. So anyone who's moving a child from Pacific Way Elementary School to a school in another part of the city, they will in all likelihood be moving their child to a place where air quality is poorer than at Pacific Way Elementary School. And that's it.
Thank you.
Thanks.